Immersing ourselves in the vastness of the universe, we humans have always questioned the possibility of whether we really are the only species to habit a planet. Gazing at the stars, contemplating distant galaxies, and exploring the potential for life beyond our little blue planet. That potential has finally materialized. NASA's director has just announced that the James Webb Space Telescope has captured something extraordinary at the edge of our cosmic neighborhood. The James Webb Telescope has once zeroed in on Proxima B, the closest potentially habitable exoplanet to Earth. We recall that a possible city created by intelligent life had been detected, which, to date, we do not know. The recent James Webb discovery shows how the brightness of the artificial light of the city of Proxima B has increased. In addition, the chemical composition of the atmosphere of this exoplanet has been discovered. So join us to this incredible journey to Proxima B to discover the details of this discovery. According to NASA's director, the James Webb Telescope may have used all this technology effectively and has detected life on Proxima B, an exoplanet located just 4.24 light-years from our solar planet. Proxima B has become a phenomenon of fame due to its potential to be habitable. This exoplanet orbits its parent star, Proxima Centauri, a red dwarf that is much smaller and cooler than our Sun. Discovered in 2016, Proxima B lies in the star's habitable zone, also known as the Goldilocks zone, which is the region around the star where conditions could allow the presence of liquid water, a crucial ingredient for life as we know it. Proxima B's proximity to Earth and its location within the habitable zone has generated enormous interest and speculation about its ability to support life. However, it is important to keep in mind that the habitability of an exoplanet is a complex puzzle involving numerous factors. Proxima B is classified as an exoplanet with a mass approximately 1.3 times that of the Earth and has an orbital period of approximately 11.2 Earth days, meaning that it completes one orbit around Proxima Centauri in that time. However, things are not as simple as we may think. The fact that the planet is Earth-like in size and orbits a red dwarf does not guarantee that it is an exact replica of our world and that we can all move there. The habitability of Proxima B is determined by multiple factors. One of them is the planet's atmosphere, which acts as a protective shield and plays a crucial role in regulating temperature and life in general. However, the exact composition of Proxima B's atmosphere is still unknown, making it difficult to definitely determine its habitability. Scientists are working on methods to study the atmosphere of Proxima B, and a key tool in this process is the James Webb Space Telescope. This telescope will allow scientists to analyze the light that passes through the exoplanet's atmosphere during transits, which will give them information about spectral characteristics and help them search for possible biomarker molecules that could indicate the presence of life. Another important factor affecting habitability is the presence of water. Although Proxima B is within the habitable zone, it is crucial to determine whether it has a sufficient amount of water to be considered suitable for life. Water is a critical piece of the puzzle, and scientists are looking for signs of liquid water on the planet's surface, whether in the form of oceans, lakes, or rivers. These clues could be key to assessing the possibility of habitability on Proxima B. The presence of water in other states, such as ice or vapor, it is also considered because water availability is essential to support biological processes and is considered a key indicator of habitability. The presence of Proxima B raises questions about its climate. Scientists must also investigate factors such as temperature, pressure, and geological activity on Proxima B to assess whether the planet is within a suitable range for life to thrive. Extreme conditions, such as a scorching heat or extreme cold, can make survival difficult. Stability is also crucial. Volcanic eruptions or seismic activity can disrupt habitability. but stability is a good sign. Proxima B is believed to be in a tidal locked state, meaning that one side of the planet remains permanently in darkness, while the other side is permanently illuminated by the star. The star contrast between the illuminated dark sides could generate temperature variations and dynamics that could affect the planet's habitability. These are just some aspects that scientists are considering in the search for habitable planets. Scientists are investigating the chemical composition of Proxima B to analyze the presence of organic compounds, such as amino acid and other molecules essential for life. They are also examining whether the planet receives enough energy from the star or other sources to fuel biological processes and allow organisms to grow, reproduce, and thrive. However, despite all these studies, the question arises as to whether Proxima B actually possesses all the necessary elements to be considered a habitable planet. Is there concrete evidence for this? Well, the discovery of Proxima B in 2016 was a remarkable achievement. Astronomers used the high-precision instrument called the High Accuracy Radio Velocity Planet Searcher, or HARPS for short, to detect the subtle gravitational tug of an exoplanet around Proxima Centauri, our nearest neighboring star. This high-precision spectrograph is designed specifically to detect exoplanets and operates at the La Silla Observatory in Chile. It has been crucial in the discovery of numerous exoplanets, including Proxima B. The HARPS instrument operates using the radio velocity method, also known as the Doppler spectroscopy technique. Its function is to detect exoplanets by measuring the subtle shifts in the star's spectrum caused by the gravitational pull of an orbiting planet. These shifts, known as radio velocity or Doppler effect, occur due to the slight wobble of the star as it is dragged by the gravitational interaction with its companion planet. HARPS has an optical fiber that collects the light from the target star and directs it to the internal spectrograph. Inside the spectrograph, the light is dispersed into its different wavelengths, allowing astronomers to study the star's spectrum in detail. In this way, scientists can determine the star's radial velocity with exceptional accuracy. To achieve the high level of precision required for exoplanet detection, HARPS uses technologies and techniques that include a temperature-controlled environment. This allowed stabilizing the instrument and minimizing the effects of thermal variations that could interfere with accurate measurements. Proxima B is an Earth-like planet orbiting the closest star to our solar system. What a coincidence! Although conditions on Earth are quite suitable for life, why settle for that when there are other planets that offer better characteristics such as balanced temperatures, fewer deserts, and a greater abundance of water? We're talking about the future of humanity, and scientists have identified some planets as prime candidates for possible colonization. These super-habitable planets, as Michio Kaku calls them, are fascinating and pose exciting possibilities for our future. Michio Kaku, the renowned physicist and co-founder of string theory, is optimistic about the future of humanity and the possibilities and opportunities that these super-habitable planets may offer. He firmly believes in the possibility of achieving immortality and, furthermore, aspires that in the future we will be able to colonize other planets and even entire universes. This idea arises due to the need to have settlements in places in case of something catastrophic happens on Earth, such as meteorite impact, supervolcanoes, or ice ages. In about 5 billion years, it is even predicted that the Sun will expand and consume Earth. The first steps to ensure our survival is to leave Earth and start colonizing other planets in our galaxy. The goal is to find Earth-like planets or even better planets called super-habitable planets that have even greater potential to harbor life than our own home. The term super-habitable planet was proposed in 2014 by Reid Heller and John Armstrong. According to them, the mere location of a planet within the habitable zone of its star is not enough to determine its actual habitability. Super-habitable planets are specific celestial bodies that offer a higher potential for harboring life compared to Earth. The common belief is that the Earth, as we only known planet with life, meets the psychochemical parameters necessary for the development of life. These parameters are key to life as we know it, and one of the essential elements is the presence of liquid water. It is for this reason that we search for exoplanets similar to Earth, in the hope of finding places where life can also exist. However, it is important to recognize that other types of planets may offer conditions equal or even more conducive to life compared to Earth. Contrary to the notion that Earth represents the pinnacle of planetary habitability, a super habitable world could also be a mood with a richer range of flora or fauna compared to our own planet. Such a world would be shown as a higher degree of environment conducive to life. It is also important to note that not all rocky planets located in the habitable zone of a star are automatically habitable. Habitability depends on a variety of factors and is not limited solely to similarities with Earth. The concept of super habitable planets can be complicated to convey as it challenges the assumption that Earth represents the pinnacle of planetary habitability. However, it is important to consider that our planet harbors an impressive array of complex and diverse life forms, suggesting that life can thrive in conditions very different from those on Earth. In the search for exoplanets, research needs to explore indicators that may reveal the existence of super habitable worlds. Among the promising targets, Alpha Centauri B has emerged. Alpha Centauri B is part of the closest star system to our planet, which makes its potential exciting. However, so far, no planets have been confirmed to be present in this system, much less super habitable planets. While there was a possible detection in 2012, it was refuted in 2015. Therefore, we do not yet know of any worlds in Alpha Centauri B. However, its neighbors, such as Proxima Centauri, are of special interest. Proxima Centauri is a red dwarf located only 4.2 light-years from Earth, making it an intriguing candidate to host not only habitable planets, but also possible super-habitable planets. Within the Proxima Centauri system, an exoplanet called Proxima Centauri B has been identified as residing in the red dwarf's habitable zone, along with other contending candidates such as Proxima C and Proxima D. Proxima Centauri B is one of the closest known exoplanets to our solar system, which has led to the question of whether this planet could be habitable. However, there are significant obstacles to life thriving here. Several variables complicate the habitability of Proxima Centauri B, such as the activity of the host star and tidal locking phenomena. The light emitted by Proxima Centauri is comparatively redder, which could reduce the interactions with certain organic compounds and decrease ozone production in the planet's atmosphere. This in turn could generate elevated levels of UV radiation harmful to life. In addition, Proxima Centauri B's orbit may be eccentric, which means that in certain parts of its journey, the planet could temporarily fall outside the habitable zone. These fluctuations could negatively affect its habitability potential. Another factor to consider is the presence of carbon monoxide in the planet's atmosphere. If these gases accumulate in excessive amounts, they could become toxic to living organisms. On the other hand, if Proxima Centauri B were to host oceans, higher oxygen concentrations could have a positive effect on the evolution of complex organisms. Tidal forces, due to tidal locking on this planet, would generate periodic cycles of flooding and drying in coastal landscapes. These cycles could trigger chemical reactions conducive to the development of life and promote the emergence of biological rhythms similar to the natural cycles we observe on Earth. In addition, similar cycles of flooding and drying would facilitate the mixing and distribution of nutrients in the oceans, stimulating periodic expansions of marine organisms, akin to what we know as red tides on our planet. It is important to mention that although red dwarfs, such as Proxima Centauri, are exceptionally long-lived compared to our Sun, their radiation is not conducive to photosynthesis as we know it. However, Proxima Centauri B might be able to support a different type of photosynthesis called anoxygenic, although its possibility is not yet fully confirmed. A 2017 study suggested that photosynthesis-based ecosystem on this planet could be about 20 times more productive than the one we find on Earth. The stability of the planet's atmosphere is a major challenge to its habitability. Even before Proxima B was discovered, researchers had been actively searching for exoplanets in the vicinity of Proxima Centauri. In the research conducted in 2008 and 2009, the lack of larger-than-Earth exoplanets in the habitable zone around dwarf stars, which include Proxima Centauri, was noted. Although these stars have on average 1 or 2 planets, only 20% to 40% of red dwarfs harbor planets in their habitable zones. Therefore, our search for a habitable planet in the Alpha Centauri system has not yielded many results so far. While it makes sense to search for exoplanets in the Alpha Centauri system, since it is the closest star system to our home, there are many other options in the vast expanse of our galaxy. So far, more than 5,000 exoplanets have been confirmed, and there are countless candidates awaiting new observations for verification. Diving into the vastness of space, there is an exoplanet called Proxima B that has a mass very similar to the Earth, and is located in the habitable zone of its star, Proxima Centauri. The closest to Earth after the Sun is a red dwarf located 4.23 light-years away from our Sun. Recently, with the help of the new James Webb Space Telescope, lights are being detected coming from the exoplanet Proxima B, which could be the latest proof that it is inhabited by extraterrestrials. However, this is not the most incredible discovery that the James Webb Space Telescope has provided us with about Proxima B. What will our new telescope have discovered on Proxima B? And how will this affect the possibility of sending a manned mission to this exoplanet? Stay with us to find about this mysterious discovery by the James Webb. If you are interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Now, what is an exoplanet? An exoplanet is a planet that orbits a star other than the Sun and therefore does not belong to the solar system. Of all the exoplanets known so far, none arouses as much interest as Proxima B. As mentioned above, the star orbiting this exoplanet is Proxima Centauri, a very cold red dwarf with a surface temperature of 2,872 degrees Celsius, 8 times less massive than the Sun and 500 times less bright. About 7 million kilometers from its star is Proxima B, which has characteristics very similar to those of the Earth, with continents, oceans, and probably life, with huge auras giving the planet a greenish color in both atmospheres, as a result of the intense flares expelled by its star, forcing the magnetic field to generate these huge northern lights. This planet is tidally locked, that is, the same face of the planet always points to its star, as happens with the Moon and the Earth. This means that the best area for life is the twilight zone. The surface temperature could be between minus 90 degrees and 30 degrees Celsius. It takes about 11 Earth days to complete a full orbit to its star, and it has a gravity of about 1.3 times that of the Earth. Scientists are not yet clear whether Proxima B has an atmosphere, but if it does, the ingredients such as carbon dioxide, rocks, and water necessary for the formation of the biochemical cycles we call life will be present on its surface. As of today, manned missions are impossible, but a project called Breakthrough Starshot, supported by billionaire Yuri Mel, is being worked on to create nanoproofs that travel at 20% of the speed of light to visit our neighbor Proxima Centauri. Estimating that the speed of these nanoproofs would be 60,000 kilometers per second, it will take a few decades to arrive, but it will help our future generations to discover secrets about its star Proxima Centauri and its exoplanet Proxima B. What will these nanoproofs find when they arrive? Well, it turns out that we have been receiving signals from Proxima Centauri. The detection was picked up by the Parkes radio telescope while investigating the star because it was emitting strong flares that caught the attention of Andrew Seaman of the University of California, who led the Breakthrough Listen project funded by Yuri Mel, which consisted of searching space for technological civilizations. This project is known as the Search for Extraterrestrial Intelligence, or SETI. They began collecting and storing all the signals they discovered for the thriving research until Shane Smith, a young college student at HITS in college, began examining the data. until we stumble upon the curious 982,000 MHz narrowband radio frequency emission hidden from view in the Proxima Centauri observations. From here, Sophia Sheikh of Penn State University took over the next signal analysis from the project and said, "This is the most exciting signal we've found with the Breakthrough Listen project, because we haven't had a signal jump like this in our data before." The Parkes radio telescope operated as follows to detect the signal. For 5 30-minute periods, the radio telescope pointed at Proxima, and then for an equivalent period of time, pointed elsewhere to check that potential signals are coming from the same target. Sophia said that over the course of about 3 hours, in 5 of the 30-minute observations pointed at Proxima, that signal returned, and when the radio telescope moved away, the signal disappeared. Referring to the importance of this discovery, astronomer Jason Wright of the University of Pennsylvania said that if you see this type of signal, and it's not coming from the surface of the Earth, you know that you just have detected extraterrestrial technology. To this date, work continues on the analysis of these signals to confirm if it comes from extraterrestrials, and with the help of the James Webb Space Telescope directing it towards Proxima B, it is believed that it could detect artificial light, and this would be the latest proof that civilization exists on this planet. Abraham Loof of Harvard University concludes that if the artificial nighttime illumination of Proxima B reaches 5% of the natural daytime illumination, the James Webb could detect this artificial light with 85% certainty. Proxima B is much smaller and dimmer than the Sun, which makes the habitable zone much closer to the star. Proxima B orbits at a distance of approximately 4.5 astronomical units from the star, which means its orbital period is about 11.2 Earth days. Proxima Centauri star is known to be quite active and produce violent solar flares that could affect the habitability of Proxima B. Additionally, the proximity of the exoplanet to its star causes its daytime side to be extremely hot and its nighttime side to be extremely cold, which could have significant consequences for habitability. Proxima B is the exoplanet of most interest to astronomers and researchers because of all the data discussed above, but it is not the only one that demonstrates Earth-like conditions to support life. In the Milky Way alone, 55 potentially habitable exoplanets have been confirmed, and those that remain to be confirmed and discovered. For example, in our neighboring galaxy, Andromeda, with dimensions similar to ours, how many habitable or inhabited planets may already exist, and also in the superclusters of galaxies. The Milky Way belongs to the Local Group, a cluster formed by about 40 galaxies, and this cluster belongs to the Local Supercluster with approximately 100,000 galaxies. Well, it is estimated there are approximately 10 million superclusters. After knowing this, just imagine that. If the Milky Way is not a very large galaxy and there are already 55 confirmed potentially habitable planets, imagine in all these superclusters and in the infinity of the unobservable universe, the number of habitable planets or even planets with life that may exist. The importance of discovering exoplanets lies in that it helps us better understand our place in the universe and answer fundamental questions about life and existence on other planets. The discovery of exoplanets allows us to explore the diversity of planetary systems and discover new forms of life that could exist on other planets. In addition, exoplanets can help us understand how planetary systems form and evolved over time. There are also important implications for the search for extraterrestrial life, as exoplanets are candidates to harbor life that can provide information about the conditions necessary for life to exist elsewhere. Finally, the studies of exoplanets allows us to test our theories and models about the formation and evolution of planets and stellar systems, which helps us advance our understanding of the universe and our place in it. If you liked the video, do not forget to subscribe, hit the like button, and if you have any questions, leave them in the comments below so we can interact with each other. See you in the next video.